All right, guys. Here we have Unit 4, Lesson 3. This is solving square root and cubed root equations. And let me just double check my recording is going on here. Yep. Okay. So we have 3 steps that we want to talk about. We always first want to isolate the radical. And remember, the radical is the proper name for the square root symbol. We're going to call it a radical because there's going to be other types of roots, like here we've got a cubed root and so forth. You want to raise both sides to the power of the root, and then we want to solve for x the way that we traditionally do. Now, I do want to talk about off to the side here our order of operations. Please excuse my dear Aunt Sally. Remember that when we solve, we want to do the order of operations backwards and in the opposite order. So the radical itself is kind of considered a grouping symbol like parentheses. So you always want to deal with that last and then reset. So you can see here with addition and subtraction, multiplication and division, that is going to isolate the radical for you. Then once you get inside the square root, you must do all the steps all over again. So remember that the opposite of a square root is to square both sides. So raise both sides to the second power, and that's going to have x equal to 64. And technically you should write 64 down here, but then here you can see there's going to be steps inside the square root. This radical is already isolated. So the opposite of a square root is yet again squaring. So we got x plus 7 equals 64. And the opposite of adding 7 is subtracting 7. And that's going to give us x equals 57. Now this is one where we have to isolate the square root first. So the 2 is multiplying, The 2 is multiplying times that radical. So the opposite of multiplying by 2 is dividing by 2. So we have the square root of x plus 6 equals 7. The opposite of square root is squaring. We've got that's 49. The opposite of adding 6 is subtracting 6. And 49 minus 6 is 43. Now, number 4 is a really good one to showcase this idea of the order of operations. So as we solve, the first thing we want to do is work from the bottom up and do the opposite. So we have to deal with addition and subtraction first. Well, we are adding 11. So the opposite of that is subtracting 11. So we got negative 4 times the square root of x equals, what is that? Negative 8. And now we work our way up to multiplication and division. The opposite of multiplying by negative 4 is dividing by negative 4. We got the square root of x equals a negative divided by a negative also makes a positive, and 8 divided by 4 is 2. And then the opposite of squaring is the square root, which 2 squared is 4. So with number 5, we're going to add 2 to both sides. Square root of x minus 2 equals 4. Then we square both sides. X minus 2 equals 16. And the opposite of subtracting 2 is adding 2. We're always trying to undo what is being done to x so we can see what it originally equaled, which in this case is 18. Okay, so now we're at the cubed roots. Gotta be careful. Make sure that you are aware of what root is being taken. If you have an index listed, you need to do whatever number that is. If there is no index listed, that is understood to be a square root, and the opposite of that is the second power. So we are going to divide both sides by negative 3 to isolate the radical. we've got the cubed root of 2x plus 5 equals 7. Now, we've got the opposite of cubing is a cubed, sorry, the opposite of a cubed root is cubing. So that's going to cancel out, and we're left with 2x plus 5. And this one's a tricky one right here. 7 to the third power. 7 times 7 is 49, times 7 again is actually 343. Feel free to use a calculator. Make sure you're doing that arithmetic right. Now we do the order of operations backwards again. We deal with addition and subtraction and then multiplication. So we're going to subtract 5. 2x equals, what is that going to be? 338 divided by 2. And what is that? 169, I believe. 338 divided by 2. I am using a calculator off screen, but I was correct. It is 169. Okay, now we're back to square roots, and this one's already isolated. This one's going to be a doozy, and we're going to use this one here as an example of ways in which we can use Desmos to do this work for us as well. But I'm going to do this with the real algebra first. We're going to square both sides. So that gives us 10x squared minus 49 equals 9x squared. So I just squared the 3 and squared the x. Since we have an x squared, we want to move everything to one side. 10 minus 9 is 1x squared minus 49 equals 0. Hopefully you remember from Unit 2 that you must solve this by factoring. There's actually a few other ways to do it, but I'm just going to stick to factoring. And we're going to have x plus 7 and x minus 7. Hopefully you identify that as a difference of two squares. You take the square root of the first thing, put it in the first two parts of those parentheses, take the square root of the last thing, put it in the last part of those parentheses, a plus between one and a minus between the other. So I'm going to go down here and do x plus 7 equals 0, subtract 7, and x equals negative 7. And then here, x minus 7 equals 0. We're going to add 7. So you got to have two answers. But there is going to be something weird that we need to talk about here in a moment. So number 7 is a very important problem. But let's move on and finish up with these notes first. We're going to square both sides. That's just going to give us 2x minus 6 equals 5x minus 15. So on both sides, the square roots cancel out, leaving just those things. Get the x's on one side and the numbers on the other. I normally like to move the lower valued x towards the higher valued x. It will ensure that we always have a positive number with our x value, so we don't get any pluses and minuses mixed up. And then I'm going to take this negative 15 at the same time and add that to both sides. That's going to give me 9. I'm going to divide by 3, and x is equal to 3. All right, final one here. We're going to cube both sides. This is to the third power, or the cubed root. 6x minus 5 equals 3x plus 2. Yet again, we're going to get the smaller valued x over and then move the minus 5 over here. So I just like to collect that smaller valued x and move it over so that we get a positive 3x here. We don't have any negatives to mess with us. And then we want to add 5 over here. That's going to cancel. I'll just double check here that I'm behaving correctly. Then we're going to divide by 3. And technically, you could leave that as a fraction, 7/3, or you could turn that into a decimal, which the squiggly equals means approximately, and it's everybody's favorite 2.67. Let's see here. Let's double check with the calculator. Oh, no, it's not. It's 2.33. Look at that. I got too excited. All right, so there's that. You could use either of those. Those are the same number, just represented different ways. Now, there's something here that we want to talk about called extraneous roots. The root word of that is extra. It is an extra root that is looks like an answer, but it's actually not. And what I'm going to do is down and split screens. And we are going to look at this number 7. So we have Desmos here. And what we can do is always do y equals the left side. It's at minus 49. And then we can have y equals the right side, which is 3x. Now look, we had two solutions here, -7 and positive. By look, remember that the intersection is what we're looking for. We only have a +7 intersection. Down here at -7, let's see. There is no intersection right here where my cursor is. So the -7 is something called an extraneous root. And the reason being, if you plug in your -7 right there, that's going to give you a -21. And when you take a square root value, you don't normally want to be able to get a negative out of there. Or at least when you're checking it, you want to always relate that to a positive number. Technically, when we take the square root of something like 9, that's asking the question, what number times itself twice gives us 9? Well, 3 and 3 give us 9, but -3 times -3 also gives us 9. So technically, we do get the positive and negative versions, but when you are checking for an extraneous root, if you get a square root equals a negative, that's normally going to be your extraneous root. It is an answer that fits algebra, but when you check it with Desmos or check it with the algebra, you can see that there's one of them is not correct. And here we can see that there is no intersection at -7. It is only at +7. So we can check this with like another one just to make sure there are no extraneous roots, such as maybe this one right here. Number 5, we got y equals the square root of x minus 2, all of that minus 2. And notice, just like last unit, the vertex is at 2, -2. And then we've got y equals 2. And look right here. Look at where the x coordinate is. It is at 18, exactly where we said x would be. And let's try this large, ugly one right here. So we have number 6, -3 times the cubed root of 2x plus 5. And then we've got, y equals, there we go. And then we've got y equals -21. And was that a negative? Did I have a negative there? Let's double check that real quick. Did I make a mistake there? That's -3. Yay, there we go. Okay, so see, sometimes you need to be careful and double check. And look right there. X is 169, exactly like we said. So you can do the algebra. That is the foolproof way to do it. That's the proper way to do it. But you could also use Desmos and double check your work. Okay, that's the way that will always get you the right answer. Y equals left side, y equals the right side. Look at where they cross, and that is your x coordinate. So I hope this helps you with Unit 4, Lesson 3, solving square root and cubed root equations. Good luck, guys, and hang in there. Have a good day.